So this is going to be a video teaching how we can solve quadratic equations with a method called completing the square. So this can be used to solve all quadratic equations. So this is a very good method. The problem is it is a little bit time consuming. The method that we're going to learn using the quadratic formula is a little bit better. So I recommend learning both methods. You are going to have to know both methods in every standard algebra class. However, the quadratic formula is a bit more streamlined than this. So what does it mean to complete the square? Well, I want us to first do a few examples where we will practice squaring a binomial. So let's look at x plus 3 squared. Now this is going to equal x plus 3 times x plus 3, which is equal to x squared plus 3x plus 3x plus 9. If you combine your like terms, you get x squared plus 6x plus 9. Okay, let's do a couple more and then we'll ask some questions about it. Okay, let's do this one. How about w minus 5 squared? That becomes w minus 5 times w minus 5, which is equal to w squared minus 5w minus 5w plus 25, which is w squared minus 10w plus 25. Let's do one more. How about y plus 7 squared? We have y squared plus 7. Well, actually, let me do it underneath. That way we'll have the work here. Y squared plus 7y plus 7y plus 49. So it's y squared plus 14y plus 49. Now notice something comparing these things. First of all, notice that we have a 6 here and we have a 9 here. Can we find a way to relate 6 to 9? Or how about 10 to 25? Or how about 14 to 49? Hopefully we're seeing a clue here. Notice that in all of these, if you take half of the middle guy and you square it, you get the last guy. Let's see if that's always true. Take 6, half of 6 is 3, and you square it, you get 9. Or half of 10 is 2, and you square it, you get 25. Or half of 14 is 7 squared is 49. So this process, okay, the process of getting this third term in there is called completing the square. So I want us to practice this. So the instructions are to complete the square, then factor. So we have t squared plus 12t. So how do we complete the square? Well, take half of 12 is 6, and you square it, you get 36. And so to complete the square, I write plus 36. This gives us t plus 6 squared. T plus 6 times t plus 6. How about this one? Y squared minus 8y. By the way, let me put a box around that to show what I've added here. Well, let's go ahead and take half of the middle guy. It doesn't matter if you make it negative or not, because when you square it, the negative goes away. So half of 8 is 4, squared is 16. So if I add 16 to this, Notice now this becomes y minus 4 squared. You can always check that by multiplying y minus 4 times y minus 4 and seeing that you actually get what we started with. Y squared minus 4y minus 4y plus 16, or y squared minus 8y plus 16. So notice it does work. We're going to do another one that's more tricky. X squared plus 3x. This is harder because we have an odd number here, but let's try it anyway. If we take half of the middle guy and we square it, notice this time that half of 3 is just 3 halves. It doesn't simplify. So square it, you get 9 over 4. So you get plus 9 over 4. So how does this factor? It's always going to be x plus half of the middle guy squared. Okay, just like these other ones, where we get this 4 from is half of 8, or where we get this 6 from is half of 12. Okay, so I think we're ready to learn the method now. So how is this useful for solving a quadratic equation? So these are going to be the steps to solve by completing the square. So step 1 is going to be divide by a, and I'll explain these steps in a moment. Step 2 is going to be to move all variables to one side of equation in descending order. All constants to the other side. Okay. If you do this, by the way, your equation will look like this. This is how you want your equation to look. Notice that all our variables are on the left and the numbers on the right. And also notice there's no number in front of x squared. And that's because of step 1. We divided by that number. Okay, so these are the first 2 steps. Step 3. You're going to complete the square. So let's remember how to complete the square. We take half the middle number, we square it, and we add it to both sides. So we're going to add half the middle number squared to both sides. Step 4, we're going to factor the left side and simplify the right side. And so you're going to get something that looks like this. Something squared equals something. Finally, step 5, we're going to solve using the square root property. If you don't know what the square root property is, I suggest you watch the other video on the square root property. I am going to review it right now, though. For the square root property, just remember that if b is greater than or equal to 0, then a is plus or minus the square root of b. And if b is less than 0, then there's no real solution. And from here, you solve. Also, last thing to say is to simplify answers if possible. Okay, so these are the steps for solving a quadratic equation by completing the square. Let's do some examples. We're going to start off easier and then get trickier. Starting with number 1. For all of these, I want us to solve using completing the square. I guess I should say by completing the square. V squared plus 10v plus 16 equals 0. So we're going to start off by dividing by a, but notice that there is no a in this problem, so we can skip to step 2. Step 2, we move all the variables to one side and the number to the other side. So I'm going to start by moving the 16 over. I get v squared plus 10v equals negative 16. Notice I've left space here, and the reason is because I know I'm going to complete the square in a moment. Step 3, take half the middle guy, square it, and add it to both sides. Well, half of the middle guy squared, that's 5 squared, which is 25. So I'm going to add 25 to the left, but I have to add it to the right also. That's the only way to keep the equation true. Now it says factor the left-hand side and simplify the right-hand side. Notice that this is v plus 5 squared. And on the right I have negative 16 plus 25, which is 9. Now 9 is positive, so that means that we can use the square root property to solve. We get v plus 5 equals plus or minus root 9. You're essentially taking the square root of both sides, but you can't forget the plus or minus. If I simplify the right, this is plus or minus 3. Finally, I get v plus 5 equals 3, and v plus 5 equals negative 3, because that's what plus or minus means. And I get v is negative 2, v is negative 8. So these are my two solutions. They're fully simplified as much as possible. Alright, let's try another one. Okay, so we're going to solve 3z squared minus 12z plus 39 equals 0. Step 1. We know we have to divide by 3 because we need the number in front of the variable squared to be 1. So I'm going to divide the whole equation by 3. I end up with z squared minus 4z plus 13 equals 0. But now I move the number to the other side. Keep the variables on one side. I get z squared minus 4z equals negative 13. Now I take half of the middle guy, which is negative 2, and you square it, you get 4. So I'm going to add 4 to both sides. Now factor the left side, simplify the right. This is z minus 2 squared. On the right I get negative 9. But notice now that negative 9 is less than 0. So this means no real solution. Which makes sense, right? You can't square something and get a negative number. So that's exactly why the last line doesn't make sense. If you're in intermediate algebra, then there is a way to solve this, and this is going to come a little bit later. This is going to be using complex numbers, which we don't do in beginning algebra. Okay, so let's try another one. 4x squared minus 24x plus 35 equals 0. This is going to be tougher. The only reason it's going to be tougher is because we're going to have to deal with fractions during the problem. So step 1, divide everything by a. In this case, a is 4, so I'm going to divide everything by 4. I end up with x squared minus 6x plus 35 over 4 equals 0. Now we move that guy to the other side. I get x squared minus 6x equals negative 35 over 4. Now we take half the middle guy and we square it. That becomes negative 3 squared, which is 9. So I'm going to add 9 to both sides. Now the left becomes x minus 3 squared. What about the right? Well, the right we have to multiply by 4 over 4 in order to get the common denominator. So we get negative 35 over 4 plus 36 over 4, which is 1 over 4. Now 1/4 is positive, so by the square root property I get x minus 3 equals plus or minus the square root of 1/4. But the square root of 1/4 is just a half, so I get x minus 3 equals plus or minus 1/2. That means that x minus 3 equals a half, and x minus 3 equals negative 1/2. For this one, I add 3 to both sides. I get x equals 3.5, which is the same as 7 over 2. And for this one, if I add 3 to both sides, I get x equals 3 minus a half. Remember, that's the same as 6 over 2 minus 1 over 2, so it's equal to 5 over 2. So my two solutions are x equals 7 halves and x equals 5 halves. Let's do one last example. This will be a tough one. We're going to pull out all the stops. We're going to solve the following. 6h plus 2h squared equals 7. Okay, notice first of all that it's not in the correct order. So let me rewrite this. 2h squared plus 6h equals 7. Now we've got it in descending order, and also I've got to take out the a. So I'm going to divide everything by 2. I get h squared plus 3h equals 7 over 2. Now we saved one step here because in this problem the constant was already on the right. So we're good to go there. Now I take half of the middle term and I square it. That's 9/4. So I'm going to add 9/4 to both sides. On the left we end up with h plus 3 over 2 squared. And on the right I get, well, what's 7 halves plus 9/4? Common denominator is 4. I get 14 over 4 plus 9 over 4 is 23 over 4. What kills students here is the fraction manipulation, not the algebra, so be very careful with the fractions. Now, since 23 over 4 is positive, this means that h plus 3 over 2 is equal to plus or minus the square root of 23/4. We should simplify this right side, though. We have h plus 3 over 2 equals, I could write this as root 23 over root 4, which is root 23 over 2. Subtract 3 halves from both sides. The way you write your answer here is negative 3 over 2 plus or minus root 23 over 2. You always put the number in front of the plus or minus. We can also combine like this. Either one of these answers are okay, so just to emphasize that, I'll box both of them. You can write your answer in either form. And that is it for completing the square. Hopefully the method is a bit more clear now. Thanks for watching.